In this lesson, we'll begin our discussion of the chemical level of organization by looking at the structure of atoms. Right? So this is known as the atomic structure. So chemistry we could think of as a science, and it deals with the structure of matter. And we're going to see that matter is made up of atoms, right? So that's this lesson. And we're also going to see there's more complex building blocks of matter, such as you may know amino acids, you may have heard of. And then we're going to see how atoms combine to form much larger, more complex structures. For instance, carbohydrates, triglycerides, proteins, DNA, right? These are much more complex structures. So, since chemistry is the study of the structure of matter, we really should know what matter is. Right? So, basically, a good definition matter is anything that takes up space and has mass. Mass basically is the amount of material in matter. Okay, so matter is made up of atoms. Like I said, that's the focus of this lesson here. Atoms are going to join together to form chemicals, and these chemicals have different properties. As an example, we know the chemical water is H2O, right? Two hydrogens are going to be bonded to an oxygen, and water has various properties. And water, guys, is going to determine, watch this, the physiology at cellular level. Now, physiology we know means the function. So different chemicals have different chemical properties or characteristics. These different chemical characteristics determine the function at the cellular level. Okay, so chemistry is important to anatomy and physiology. So let's take a look at some structures known as subatomic particles. These are important because they help us to understand the properties of matter. The three that I'd like you to know are protons, neutrons, and electrons. So protons, these are positively charged subatomic particles. We find them in an atom in the nucleus. Now, these do contribute to the mass of the atom, and we give them a value of 1 mass unit, right? We could even say at 1 atomic mass unit. You sometimes see the abbreviation AMU. All right, so protons live in the nucleus, and they do contribute to the mass of an atom. The second subatomic particle is also located in the nucleus, but this one does not have a charge. It is neither positive nor is it negative. Okay, so we say that it is neutral, but it does contribute mass. Just like a proton, it has 1 mass unit. All right, so we'll see that protons and neutrons both live in the nucleus, and both of them contribute to the atomic mass of the atom. Electrons, these have a negative charge, right? So these are negatively charged. Now, for our purposes, we're going to say they actually have no mass. They're not going to contribute mass to the atom. We really don't care about these too much as far as contributing mass. But the real answer is they do have some mass. They're low mass, right? They're 1/1836th of a mass unit. You don't have to know that number. I just think it's kind of interesting. Electrons, though, are not located in the nucleus. They are located in the area around the nucleus, and they're moving about. They're not just stationary. This is known as the electron cloud. Okay, so these are a little bit different. They have a negative charge, and we find them outside of the nucleus. All right, so here's an example of an atom. This happens to be a hydrogen atom. This middle part here is where the nucleus would be, right? So in any atom, a proton and a neutron would be living in here. And then out here, this whole area is the electron cloud. So the electrons will, they don't just sit like if my cursor was an electron, they don't just sit like that. They actually, move around in different patterns, that type of thing. So we can find them anywhere in this electron cloud. Okay, so this is an important slide. Protons, neutrons, and electrons. They're all known as subatomic particles, and they help to make up the structure of the atom. So let's look at that, the atomic structure. So how do we know how many protons, neutrons, and electrons an atom has? One of the things that you just kind of keep in the back of your mind is the number of protons, and I'll show you how you find that in a minute, is going to equal the number of electrons, right, in a neutral atom, right? So they're going to be the same. Right? We will see that the number of neutrons can vary, but we'll talk about that separately. So let's review the nucleus again. We said before that the nucleus contains both protons and neutrons. So there are two numbers on your periodic table if you could take a look. There's one known as the atomic number, and then the other one is known as the atomic mass number. So on your periodic table, if you just kind of look at this example up here, this is the key. This happens to be the element carbon, right, which contains carbon atoms. So if you look in the lower left corner, there's a number there. That atomic number tells us the number of protons. So carbon has 6 protons. And now we also know that the number of protons equals the number of electrons. So we know that carbon also has 6 electrons. This atomic number, guys, if you notice, if we start here on the left, each element has a different atomic number. Here's carbon, right? Notice no atomic numbers are the same. It is the atomic number or the number of protons that makes each element different, right? So that's important. You'll never see two different elements having the same atomic number. They're always going to be different. Okay, so the atomic number, again, you're going to find it in the lower left-hand corner. And what does it indicate to you? The number of protons. And like I said up here, the number of protons in an atom equals the number of electrons. Right? So it's kind of giving you two things, the number of protons and the number of electrons. Now, the second number that we'll look at is known as the atomic mass. And sometimes they say atomic mass number. If you look up in the top corner here, on carbon, it happens to be 12.001. So this is the mass of the carbon atom. Now we said on a previous slide, what contributes mass? Mass is contributed by the proton and the neutron. So let's watch this. Let's just round this number to 12. Forget the 0.011 right now. Just know the number 12. If I said to you the atomic number of carbon is 6, that tells us we have 6 protons. That's counting 6 of this atomic mass. That means how many neutrons would we have? We would also have 6, right? Because it's the 6 protons plus the 6 neutrons that give us the atomic mass. So that's how we would calculate the number of neutrons. We can just take the mass, subtract the protons, because that contributed mass, and that would leave over the mass of the neutrons. And what did we say before? Each neutron has 1 mass unit. Yeah, so it's a quick way to figure out how many neutrons. Okay, so the atomic number, again, these are important numbers. Atomic number is the number of protons. You're going to find it in the lower left-hand corner of the periodic table. And then the atomic mass, or the mass number, is the number of protons and neutrons. Right? And if you know the number of protons, you can subtract it from the number, that's the mass number, and that will automatically tell us how many neutrons we have left over. Okay, so atomic number and then atomic mass. So now we know the nucleus. How about the electron cloud? So this is a spherical area that contains the electrons. If we were to do this from a two-dimensional perspective, we actually usually draw electron shells, and we can see that the electrons are going to be in these electron shells or energy levels. But the electron cloud itself is this spherical, where's that one picture? I'll show you right here. Again, this whole big spherical area that we would find the electrons circulating around at any time. right, we'll talk about the electron shells in the next lesson. Okay, so on your periodic table, there are some elements that I want you to know. You can actually, I highlighted them for you. You can do the same thing here. You could let's highlight first. Let's highlight oxygen. So I do want you to know the symbol and the name, right? You don't have to memorize the atomic numbers or anything like that, but I just want you to know at least the symbol and the name of the atom, right? So oxygen, guys, is going to be the letter O, and this is one of the main atoms that are involved in water, right? H2O. So that's one that we're going to see a lot all semester. It's in a lot of other organic compounds like carbohydrates and proteins. And we know also, what do we breathe in? We breathe in oxygen, right? So it's an important part of our respiratory system. Right to the left of it, two over, is carbon. That's a big one. Carbon is the letter C, and this is a big part of organic chemistry, which we're going to study at the end of this chapter. Way up here in the left corner here, this is hydrogen. This is the simplest atom, right? The simplest element has an atomic number of 1. This again, just like oxygen, is a main contributor of water, and we see it in a lot of organic compounds. All right, so that's the letter H. Go between carbon and oxygen is nitrogen. This one we see in some of our proteins, amino acid structures. A lot of amino acids have nitrogen. It's part of DNA, RNA. Okay, I should say actually all amino acids have nitrogen, not some, all amino acids. So we do see nitrogen as a big part of our protein structure, part of our DNA structure, RNA structure. These are things we're going to look at in subsequent lessons. Go over to the left, down over here, Ca. So this is calcium, right? We can't just say C because carbon was just a C. Calcium is a big part of muscle contraction. It has to do with electrical nerve transmissions, membrane function. So calcium is an important one we're going to see all semester. Phosphorus is another one over here, right below nitrogen. Phosphorus is a major contributor to the inside of a cell, so it's part of our normal inside anatomy of the inside of a cell. Phosphorus is also part of energy. Have you ever heard of ATP, adenosine triphosphate? Right, that's an important one. It's part of DNA and RNA. Again, guys, these are all things that you're going to learn as we go through the semesters. For now, I just want you to know the symbol and kind of an idea where they are in the periodic table. Potassium, if you go way over here to the left of calcium, now notice potassium is not written as a P, right? You would think potassium, it would be as a P. They actually use the Latin name Kalium, K-A-L-E-U-M, which you don't have to know. I just like to explain it because that's where the K comes in, Kalium. Potassium is also an important element or atom for nerve transmission, muscular contractions, and things like that. Okay, what else we have? Sodium. Go right above potassium. Here's sodium. Now, again, you would think sodium would be an S, right? Sodium, S. But they use the Latin name natrium, NAT. So they use Na for sodium. Sodium, we're going to see very closely with potassium always. These two are important in nerve transmission as a good example. Go all the way over to the right. Chloride right here, Cl, right? Chlorine. This is going to be the abbreviation Cl. This is also important in electrical transmission, cell membrane function. It's just something that we will deal with a little bit this semester. Right between chlorine and phosphorus is S, is sulfur. This is found in a number of proteins, right? We do have some proteins, some amino acids. One of them is cysteine, is an amino acid that has sulfur in it. Okay, Fe is iron. Right? This is something that we see in anatomy too. This is an important thing in the anatomy and physiology of a blood cell, iron. And then another one you're going to see in anatomy and physiology too over here, guys, is iodine. This is important in making thyroid hormone, believe it or not. This is important in making thyroid hormone. Just so you know, there are a number of trace elements. You don't have to highlight these, but these are trace elements that we found in minimal amounts in the body. And I just want to kind of impress upon some of them. We have silicon, fluorine, copper, selenium, aluminum, tin. These are all things that are found in the earth but have become part of our normal anatomy and chemical structure. Okay, but the ones that we have highlighted in red here are the ones that I want you to know. Okay, again, so on this table here, you're going to just have to know the name and the symbol. This here, this is more of an FYI. I'm not going to ask you this stuff right now as far as the function, in the body. We'll learn that as we go through the next couple semesters. Okay, so each one of these boxes is an element, right? It's a different element. That's what we've been looking at. So an element is a pure substance composed of atoms of one kind, right? In carbon, there are only carbon atoms. No other atoms would be there. Okay, the atomic number, like I said before, the number of protons in an atom determines its chemical properties. And again, if you notice, every element has a different atomic number. That means it has a different number of protons and also a different property. Okay, so that's important. And I put it here again. Each element contains a different atomic number. Now, you may hear of something known as an isotope. This is where we have a difference in the number of neutrons. Okay, so the neutrons can vary from one atom or another of the same element. So these are versions of elements based on mass number. Okay, the mass number we said before is the number of protons plus the number of neutrons. Only the neutrons in an isotope are different because the number of protons always stays the same. So just to give you an example, here's hydrogen. If you go look at your periodic table, you'll see that hydrogen, let's actually take a look at it right here. Hydrogen has an atomic number of, let's go to one where we can see it, has an atomic number of 1. That means there's one proton, but it has also a mass of 1. So that tells you, for the most part, there's no neutrons, only a proton. But we do have different forms of hydrogen known as isotopes, where you have one proton here. This would be known as hydrogen 1. It has one proton, one electron, because those are equal. But on this one, guys, here, there's no neutron. But there are other forms of hydrogen where there's a proton and an electron, but notice this one has a neutron. This is an isotope of this one. And then there's also one where we have three, one atomic mass of 3, a proton, and this one has 2 neutrons. So this would have a bigger atomic mass than this one. This one has a bigger atomic mass than this one. So that when you look at them in nature, this is the one that exists mostly, that the atomic mass is actually 1.00714, that type of thing. It tends to be more towards 1. It's not an average of the 3. The one that exists more in nature happens to be this one, right? So you don't have to know these names, hydrogen 2, hydrogen 3. Just notice that most atoms can vary in their atomic mass, and that's based on the number of neutrons. Now, a lot of these isotopes are actually radioactive. And they can release radiation, so they can be harmful, but they do use weak radioisotopes for diagnostic imaging. For instance, if anybody knows somebody that went for a thallium stress test, right, they're actually giving isotopes for the diagnostic imaging, right? And if you ever talk to somebody that has diagnostic imaging using radioisotopes, right, they can't be near pregnant women because again, it could do damage to the embryo. Okay, so an isotope is an element or an atom that varies in the number of neutrons, right? These are all hydrogen, but notice again, each one has a different number of neutrons. Okay, so we know now the nucleus. Let's take a look at these actual electrons and the energy levels. So we said before that the electrons are in the electron cloud, but now we're going to add something. It is the electrons that determine how reactive an atom is. Basically, guys, that means how easily will they enter into a chemical reaction and form bonds. And that's going to be our next lesson, actually. So our electron cloud consists of these energy levels, right? So electron cloud contains shells or energy levels, and each energy level holds a certain amount of electrons. And we always fill from the smallest energy level outwards to the bigger energy levels, right? So the lower shells will fill first. We'll see as an example, the first shell can only hold 2 electrons. Once that is filled, additional electrons are going to go into the second shell, and that can hold a maximum of 8 electrons. The third shell can hold 18, and then the number gets bigger as we go out. For our purposes, the first couple lessons of chemistry, we're going to just kind of be hanging out right here in the first, second, and a little bit into the third shell. Okay, um, the outermost shell is known as the valence shell, right? And that's going to be what's important there is the number of electrons in that shell. That is the shell that will determine what type of chemical reactions the atom is going to go into. All right, so what's important here is that the electrons are in energy levels. The first energy level holds 2 electrons. The second energy level holds a maximum of 8, and the third one can hold a maximum of 18. Okay, if there's more electrons than that, then they would go into the fourth energy level. And again, that's way beyond the scope of this course here. So you can actually see for each element the number of electrons for each energy level. So for carbon, so watch this, carbon has the atomic number of excuse me, atomic number of 6. That means there are 6 protons, but it also means there are 6 electrons. So watch this, guys. The first 2 electrons are in the first shell. That means how many electrons are in the second shell? A total of 4. Okay? If we look at, just make this bigger for a second here, watch this. If we look at oxygen, oxygen has an atomic number of 8. That tells us 8 protons. It also tells us how many electrons. 8 electrons. So 2 are in the first shell, and that means the remaining 6 are going to be in the second shell. Okay, let's go back for a second, make sure we got everything. Whoops. All right, so the valence shell, again, is just the name that we use for the outermost shell, and I'll talk about that in our subsequent lesson on chemical bonds. All right, so just a couple quick pictures and we'll finish up this lecture. So here they're actually showing you, again, hydrogen. So if you take a look at your periodic table, up in the top left-hand corner, if I were to ask you, what's the atomic number? The answer is 1. What's the atomic mass? We're just going to round it off. We're going to say 1. So now that we know we have 1 proton, the number of protons equal the number of electrons. This is the way this 1 electron would be in that first energy level. If you go to the top right hand corner, way up here, I didn't talk about this one, helium. This is something we don't have in the body, but helium is an atom that has the atomic number of 2, and its mass, we're going to round off, is 4. Right? So it has atomic number of 2, its mass is 4, so that tells us we have 2 protons, 2 electrons, and how do we figure out the neutrons? We take the mass and subtract the protons, and that will tell us the neutrons. So you can see 2 protons, 2 neutrons. Now watch this. The first energy level has 2 electrons in it. This one is now full. We couldn't put any more electrons in this energy level because we said before it only holds 2 maximum of electrons. Just to go a little bit further, lithium, if you take a look on your periodic table has the atomic number 3. So what does that tell us? It has 3 protons, 1, 2, 3. It also tells us it has 3 electrons. Right? Remember we said protons equal the electrons? 1, 2. But notice, guys, this first shell is full, whereas that third electron is in the second shell. Okay, so it's not in the same energy level. And then we could also figure out the number of neutrons. If you take a look at the atomic number on your periodic table of lithium, it has a mass number of 6. So how do we get the neutrons? Just take the mass number, subtract the protons, that gives us the neutrons. If you want to see neon, which is a noble gas they call it, look way over to the right. Go to the atomic number 10. So that tells us we have 10 protons, so we would see 10 protons in the nucleus here. Its mass is 20, so that tells us we have also 10 neutrons. And then the number of electrons equals the number of protons. So how would these electrons fill? So there's 10 electrons. The first 2 are in the first shell. That's full. We can't put any more in there. So that means the remaining 8 have to be in the second shell, and the second shell can hold 8. So look at this. 1, 2, 3, 4, 5, 6, 7, 8, right? So this one is full. Now, if there were other electrons, they would have to go in the next shell, and so on. Okay, so that concludes this lesson on atomic structure. In the next lesson, we'll now take this information and we'll see how these atoms will combine to form chemical bonding.